Good evening, dear students. So this is the fifth session on vector algebra, and in this session we are going to solve few questions based on scalar product or dot product. So the previous session knowledge, that is the session 4, in which I described the scalar product in details with its different properties. So that knowledge is very important to understand the questions I am going to solve here. So those who are not looked into the session 4 of vector algebra must have a look into the session 4 first, and then look into this session, that is the fifth session. So before I proceed further, I just want to get a confirmation that you are able to hear my voice very clearly and able to
Yes, sir.
view the screen
Yes,
properly.
sir.
Okay, great. So dear students, the first question, what is that? Find the angle between two vectors A and B with magnitude 1 and 2 respectively, and A dot B equal to 1. Okay. So what are the preconditions? The precondition is that the second one is A dot B equal to 1, that is given, and magnitude of the vectors 1 and 2, if magnitude of the vectors A and B are 1 and 2 respectively. What does it mean? That means mod of the vector A is 1 and mod of the vector B is 2. So these are the information given to us, and what we need to find? We need to find the angle between these two vectors. So we know one thing, dear students, that the dot product A dot B is equal to what? Is equal to mod of A into mod of B into the cosine of the angle between these two vectors A and B, that is cos theta. So from this we are able to find theta equal to cos inverse, or I can say, if you forgot inverse trigonometric function. So from here what we can write? From here we can write cos theta is equal to A dot B divided by mod A into mod B. Now from here we can get the theta equal to cos inverse of A dot B divided by mod A into mod B. Now what is A dot B? A dot B is equal to 1, that's what it is given here, na? And mod A is 1 and mod B is 2. So mod A into mod B is 1 into 2, that is 2. So cos inverse 1 by 2, and we know the value of cos inverse 1 by 2 is pi by 3, and we get the answer, that is the angle between the vectors A and B, as pi by 3. I hope you got a very clear idea. So here we use the formula that A dot B equal to mod A into mod B into cos theta. From there we find the value of theta. Now let me go to the next question, and next question I am going to place in front of you. At any point of time, any question, if you have any smallest doubt, never hesitate to let me know about it. So the next question here, dear students, so here it mentioned find angle theta between the vectors A, that is equal to I cap plus j cap minus k cap, and B equal to I cap minus j cap plus k cap. So both the vectors A and B are represented in the component form, correct? So we need to find the angle between these two vectors. So let us assume theta be the angle between these two vectors. Theta be the angle between these two vectors A and B. Then what we get? Cos theta. Cos theta equal to, we know that A dot B by mod A into mod B. And we know when two vectors are given in the component form, their dot product is nothing but the product of the component I cap, j cap and k cap, and finally their summation, means product of I cap and I cap, that is 1 into 1, because that both I cap for vector A and B are having the coefficient 1. So 1 into 1, that is 1, this one. And then j cap and this j cap. For the vector A, j cap coefficient is 1, and for vector B, j cap coefficient is -1. So 1 into -1, that is equal to -1. And for the vector k cap, you see that not for the vector k cap, sorry, for the vector A, the k cap component, that is coefficient of k cap, is -1, and for the vector B, the coefficient of k cap is 1. So that means it is equal to -1 into 1, that is -1. So 1 minus 1 minus 1, that becomes -1. So that is A dot B. And what is mod A? Mod A we can find. So as the vector A is given, we can find mod A. If you recall, that is nothing but square root of the sum of the coefficients of I cap, j cap and k cap. So what is the coefficient of I cap? For the vector A, it is 1. So it is 1 square plus what is the coefficient of j cap in the vector A? It is 1. So 1 square. And what is the coefficient of k cap for the vector A? It is -1. So that means plus -1 whole square. So that is actually become square root of 3. In the similar manner, we can find the modulus of the vector B. So that is equal to mod B. What is mod B, dear students? So that is equal to square root of I cap. What is the coefficient of I cap for the vector B? It is 1. So it is 1 square plus what is the coefficient of j cap for the vector B? That is -1. So -1 whole square plus what is the coefficient of k cap for the vector B? That is 1. So that is equal to 1 square. Now if we find the value, that is also becomes square root of 3. Now this square root of 3 and square root of 3, if we multiply these two, so we get 3. That means mod A into mod B become square root of 3 into square root of 3, so that become 3. So finally we get the value of cos theta equal to -1 by 3. Hence we get the value of theta equal to cos inverse of -1 by 3. That is the angle between the vectors A and B, okay, as it is asked in the question. I hope it is clear, and we can proceed to the next question. Okay, dear students, so next question I am going to place in front of you. Okay. Okay. If you look into the next question, dear students, the here question is, if A, the vector A is equal to 5 I cap minus j cap minus 3 k cap, and vector B is equal to I cap plus 3 j cap minus 5 k cap, then so that the vectors A plus B and A minus B are perpendicular. So dear students, if you recall from the previous session that we discussed that when two vectors are perpendicular, then their dot product is equal to 0. So for example, that if there are two vectors, one vector is P and another vector is Q. Suppose we say that the vector P is perpendicular to the vector Q. Then what we can conclude? We can conclude that that the vector P dot vector Q, that must be equal to 0. So if two vectors are perpendicular, that means P dot Q equal to 0, and the converse is also true. That means what? If P dot Q equal to 0, then we can conclude that the vector P is perpendicular to vector Q. That's why it is both implied and implied by, implying and implied by, both the arrows, right? So what we need to show in this case? In this case we need to show that A plus B dot A minus B equal to 0. That should be our purpose. Okay, why? Because we need to show that these two vectors are perpendicular. The first vector is A plus B and the second vector is A minus B. Now as the vector A and B are given in the component form, it is quite simple to find the addition of their vectors and the difference. of these two vectors. So when A is given as 5 a cap, 5 I cap, minus j cap plus minus 3 k cap, and B vector is given as I cap plus 3 j cap minus 5 k cap, obviously A plus B is equal to the addition of their corresponding I cap component, that is 5 plus 1, that is equal to 6, here it comes. Then j cap component, that is minus 1 plus 3, that is equal to 2, and k cap component, that is minus 3 and minus 5, that becomes minus 8. So this is the k cap component. So we get A plus B as a vector which is represented in the component form as 6 I cap plus 2 j cap minus 8 k cap. Now in the similar manner we can find the value of A minus B, that is the difference of the I cap coefficient of I cap for both the vectors A and B. So it is 5 minus 1 for I cap, that is 4 I cap, here it is. Then minus 1 j cap plus 3 j cap, that becomes plus 2 j cap, minus 1 minus 3, I'm sorry, minus 1 minus of plus 3, that is minus 3, minus 1 minus 3, that is minus 4 j cap, and minus 3 k cap and plus 5 k cap. Why? Because minus of minus 5 is plus 5, so minus 3 plus 5, that is plus 2 k cap. So we have two vectors. One vector is 6 I cap plus 2 j cap minus 8 k cap, and the second vector is 4 I cap minus 4 j cap plus 2 k cap, and we need to show that these two vectors are perpendicular. So for that, what you will do, you will make a dot product of these two vectors, and dot product, we know when the vectors are represented in the component form, it is the product of their corresponding I cap coefficient, then j cap coefficient, then k cap coefficient, and their addition. It should be 0. So here it is 6 I cap plus and 6 I cap and 4 I cap, that's 6 into 4, that is 24. Then plus 2 j cap minus 4 j cap, that is plus 2 into minus 4, that is minus 8. And then minus 8 k cap plus 2 k cap, that is minus 16 k cap. Okay, so 24 minus 8 minus 16, that is equal to 0. So you are able to show that A plus B dot A minus B equal to 0. Hence we can conclude that A plus B and A minus B are perpendicular to each other. I hope you got a very clear idea about the question and the way I derived. Okay, now let's proceed to the next question. And next question I am going to place in front of you. So the question here is, find the projection of the vector A 2 I cap plus 3 j cap plus 2 k cap on the vector B I cap plus 2 j cap plus k cap. Okay, so if you recall the projection formula, so that means what, we have a vector B here. I can give you a that symbolic representation. Suppose this is the vector B, okay, and there is a vector A here. Suppose this is the vector A. Just a minute, let me draw the vector properly. Suppose this is the vector A. Okay, so we need to find the projection of the vector A on B, on the vector B. So that means projection of A on the vector B. For that, you recall that we complete this one, and angle is also required, and that angle we find it out by means of that dot product. But the formula is that the projection of a vector A on the vector B, this is the formula, A dot B by mod B. So as both the vectors A and B are given in the component form, it is quite simple to find A dot B. That is 2 into 1, that is 2, plus 3 into 2, that is equal to 6, plus 2 into 1, that is 2. So 2 plus 6 plus 2, that is equal to 10. We get it here. And square root of the mod b. Mod b means what? Square root of 1 square plus 2 square plus 1 square. So that is square root of 6. So 10 by square root of 6, and it is actually equal to 5 square root of 6 by 3. I hope you got a very clear idea. So why I didn't write as 10 by root 6? Because it is better to rationalize. Denominator irrational number is not a good thing, so we should rationalize. Hence we multiplied both numerator and denominator by square root of 6, and then simplified, we get 5 by 3 square root of 6. I hope you got this one very well. Again, if you do not understand what is the projection and how come this formula came, that projection of a vector A on the vector B as A dot B by mod B, you please look into my previous session, that is session 4 on vector algebra. Alright, now let me go to the next question. Okay, so next question I am going to place in front of you. The question here is, so let me first place it, and after that I will explain. So dear students, so here the question is that find mod A minus B of two vectors A and B such that it is given that mod A equal to 2, mod B equal to 3, and A dot B equal to 4. It's a slightly different type of questions where you really cannot use a exact formula, exact formula whatever we have learned directly, but it is based on that. Okay. So one thing, mod of A minus B whole square, that is equal to A minus B dot A minus B, and that is coming from a formula. If you recall, mod of, if you recall this formula, mod of A, that whole square is equal to A dot A. How come that? A dot A, remember, A dot A means mod A into cos of the angle between A and A. A and A angle, the angle between the vector A and itself is 0. So cos 0 is 1, hence it is mod A square. So here, instead of A, based on this formula, what we get, it is A minus B. So A minus B, mod of A minus B whole square is equal to A minus B dot A minus B. Now we are applying here the two properties we have learned of from the scalar product, that is mod A distributive property, mod A into mod A dot A minus A dot B minus B dot A minus into minus 1 into minus 1 is plus 1 B dot B. We know A dot A is equal to mod A square, and we know the scalar product is commutative. That means B dot A is equal to A dot B. So that means whatever you see B dot A here, that we can write as A dot B. So it becomes minus 2 into A dot B, and plus B dot B is equal to mod B square, right? This one. So then what we get? Mod A is given. Mod A is given is 2. So 2 square minus 2 into A dot B is given as 4, and mod B square, that is equal to 3 square. So 2 square minus 2 into 4 plus 3 square, and it becomes actually 5. So then we make a square root of mod of A minus B, that is equal to plus square root of 5. We should not consider the negative one, because mod of a vector cannot be negative. Okay, modulus of a vector cannot be negative, hence we are considering the positive value. So I hope you got it. So here we need to apply a little bit our understanding based on this formula. This is the underlying formula, and that formula we applied on a vector called A minus B, and we get it. So very likely to come questions based on this in your board examination. So please take a note of it and see the way it has to be done. Okay. Now let me go to the next question, and next question I am going to place in front of you. So dear students, so here the question is, if A is a unit vector and x minus A means x is also a vector, x minus A dot x plus A is equal to 8, we need to find the magnitude of the vector x. That is the question. So one condition is given, A is a unit vector. A is a unit vector means what? Mod of A is equal to 1. So now according to the question, x minus A dot x plus A is equal to 8. So that is given. Now we are using the distributive property, so that becomes x dot x plus x dot A minus A dot x minus A dot A is equal to 8. We know the scalar product is commutative. That means x dot A is equal to A dot x. Now one is plus, one is minus, so it will get cancelled, correct? So we get x dot x, that means nothing but mod x square, and A dot A, that means mod A whole square. Mod A is equal to 1 because A is a unit vector, so mod A whole square, that should also be equal to 1. So we get mod x whole square minus 1 equal to 8. That means mod x whole square is equal to 9. From here we find the value of mod x equal to 3. Generally, if you see in algebra, that if we say something called y square equal to 9, so we know from our understanding of algebra y is equal to plus minus 3. Here also like this, based on algebra, that mod x whole square equal to 9 means mod x equal to plus minus 3, but we cannot consider the negative value. Why? The magnitude of a vector, that is mod x, cannot be negative. So though you can write it here, from here you can write mod x is equal to plus minus 3, but we at the same time we need to write but mod x cannot be less than 0. Hence we get the positive value, that is mod x equal to 3. I hope you got a very clear idea about this question. Okay, now let me proceed to the next question, and next question I am going to place in front of you. Okay. So dear students, here is the next question. Sorry. The question here is that for two vectors A and B, we always have mod of A dot B is less than equal to mod A into mod B. That is known as Cauchy-Schwarz inequality, and we can prove it very easily by means of dot product. So what we need to show? We need to show that mod of A dot B is less than equal to mod A into mod B. That means what? There are two things, that is equal to mod A into mod B, correct? That is one case, and another one is that less than mod A into mod B, because according to the question, that is Cauchy-Schwarz inequality is less than equal to, so there is a equal and there is a less than. Now when equality occurs, if A is a 0 vector, that means null vector, then mod A will be what? 0. If A is equal to 0 or B is equal to 0, then we get what? A dot B, that is equal to 0. 0, how come we can say this thing? Mod A into mod B, that is 0 vector into that mod of 0 vector into mod of 0 vector, that is 0. Right hand side is 0 and left hand side is 0 dot 0. That means what? Mod 0. So if we write 0 vector dot 0 vector means null vector dot null vector, that is equal to what? Mod of 0 vector into mod of 0 vector. And what is the angle between 0 vector and 0 vector? Is 0, because they are same vector, angle between them is 0, so cos 0. Okay, so 0 vector, so that is equal to 0, mod 0 is 0. And in the right hand side, if we see 0 vector dot 0 vector, so what is the mod of the 0 vector? Magnitude of the 0 vector is 0, 0 into 0, that is equal to 0. So equality holds true when either mod A equal to either A equal to 0 vector or B equal to 0 vector. Okay. Now suppose the other case is that mod A is not equal to 0 and mod B is not equal to 0. That means what? Both the vectors are non-zero. Then what we will get, dear students, that mod of A dot B is, so from we know one formula, that A dot B, that is a very fundamental formula of dot product, that is the foundation. So mod A into mod B into cos theta. So from here we can write, so from here what you can write, so from here we can write, this implies A dot B divided by mod A mod A into mod B, that is equal to cos theta. Now we are taking a mod of both the sides, so that means A dot B become mod of A dot B, and mod A into mod B mod will be same thing, mod A into mod B, because mod of mod x equal to mod x only. So that is equal to mod of cos theta, and if you recall, dear students, the value of cos theta is always between -1 to +1. That means what? Mod of cos theta will be definitely less than equal to 1. So we see that mod of A dot B by mod A into mod B is less than equal to 1. That means what? Mod of A dot B is less than equal to mod A into mod B. I hope you got a very clear idea, and never hesitate to let me know if something is not clear. Okay, so that is a good inequality, and we are able to prove it. Okay. Now let's proceed to the next question, and next question I am going to place in front of you. Okay. So dear students, so let me read out the question first, and after that I will explain you. So the question here is that for two vectors A and B, we always have mod of A plus B is less than equal to mod A plus mod B, and that is known as triangle inequality. Okay, so previous one we discussed about the Cauchy-Schwarz inequality. You recall this one, that is, I go back to this one, Cauchy, and this one, that where we see that mod of A dot B is less than equal to mod A into mod B. Here it is plus mod of A plus B is less than equal to mod A plus mod B, and this is known as triangle inequality. Obviously, if you apply the fundamental understanding of that vector represented in the three sides of a triangle. So if you consider the vector AB as vector A, vector BC as vector B, and if you see the AC will be the vector A plus B, and obviously if you look into this triangle, obviously the modulus of the vector A dot A plus B, that means the value of the side AC is always less than equal to the sum of the other two sides, that is the modulus of the other two vectors AB and BC. That we always know, na? In a triangle, any side is always less than equal to the sum of the other two sides. Okay, that is from our common sense. But how to prove it? Now again, in the previous case, what we can say is that when we write according to the question, what we need to prove is that mod of A plus B, so that has two things. One is that is equal to mod A plus mod B. Okay, and another thing is that is less than mod A plus mod B. So there are two things, one is equal and one is less than. So when it will be equal, dear students? When both the vectors are zero vector, means any one of the vector is a zero vector. It can happen that both are 0, so that's why we use the word or here. Either A is a 0 vector or B is a 0 vector, then what we get, obviously if you see the one, if you apply, suppose A is a 0 vector, then what will happen? Mod of A plus B will be mod B, and right hand side will be 0 vectors magnitude is 0 plus mod B, so mod B equal to mod B, so possible. Similarly, B is a 0 vector, then also it is possible, and if both the vectors are 0, then also it is possible. Fine. Now let's take the case that when that A is not a 0 vector and B is also not a 0 vector. That means mod of A is not equal to 0 and mod of B is not equal to 0. In that case, what is going to happen? We are going to take the help of that formula. If you remember that mod A whole square equal to A dot A. Okay. So what we are going to do is that mod of A plus B whole square, that is equal to A plus B into A plus B. Sorry, A plus B dot A plus B. Into means I wanted to mean the scalar product dot. So what I say is that mod of A plus B whole square, that is equal to A plus B dot A plus B. Now distributive property we are applying, that is equal to A dot A plus A dot B plus B dot A plus B dot B. Now we know A dot A is equal to mod A whole square and B dot B equal to mod B whole square. Then what is there in between is A dot B and B dot A. We know that scalar product is commutative, so B dot A is equal to A dot B, so we can consider this together and we get 2A dot B. So what we get, mod A whole square plus 2 into A dot B, 2 into mod of A dot B plus mod B whole square. How come we can write this thing? So what we wrote here, so this is very important statement here and I want to spend some time here. So what we wrote is that, let me write it here, mod of A whole square plus 2 into, here it is A dot B plus mod B whole square, correct? Now if you look at it, that in the next step we wrote what? Next step we wrote mod A whole square plus 2 into mod of A dot B plus mod B whole square. We wrote a less than equal to sign, so we will come to that one. So I am not discussing the less than equal to at this moment. So these two are same, this one and this one are same, so we are not considering. This one and this one also same, we are not considering because they are equal. 2 and 2, they are also equal, we are not considering. So now it comes is that A dot B and mod of A dot B. So we are writing that A dot B is less than equal to mod of A dot B. How come? See, for any real, A dot B is what? A dot B is a real number, right? A dot B is a real number. So if we consider the real number as x, any real number is always less than equal to mod of that real number. So for all x belongs to R. How come? Because x can be either positive or negative, but mod x should be always positive. So suppose x is positive, then x is equal to mod x, correct? Na? Means if I elaborate, if x is greater than 0, in this case what you can write, that x is actually equal to mod x. Now if x is less than 0, this implies what? That x is less than equal to, in this case we can strictly write less than mod x. Suppose x is equal to minus 5, less than 0, let us take a value minus 5. So minus 5 is less than mod of minus 5, which is 5. Minus 5 is always less than 5, na? So that is why we are writing x is less than mod x. So always remember this thing, very important. X is less than equal to mod x for all x belongs to R. We discussed this thing in the last year in our class 11 during the discussion of modulus. So now let's come back. So that means what? So here then we can write here this is less than equal to, that means here we apply the sign less than equal to, because A dot B is less than equal to mod of A dot B. So that is equal to, that is what we can write is that mod A whole square plus 2 into mod A into mod B, because we know mod of A dot B is always less than equal to mod A into mod B. We just discussed one question earlier, okay, means the previous question, if you recall, there we have discussed, okay. And then what we can write is that plus mod B whole square, correct. So then what we can get is that mod of A dot B. So here if I come back again once more, mod of A dot B is less than equal to mod A into mod B, that we have done it here, okay. That is the Cauchy-Schwarz inequality, here we have done, no? So mod of A dot B is equal to, here if you look at it, this one, mod of A dot B is less than equal to mod A into mod B. So here also we wrote this thing, the same thing sorry, that mod of A dot B is less than equal to mod A into mod B. So then mod A whole square plus 2 into mod A into mod B plus mod B whole square, that is nothing but mod of A plus B whole square. So what we get? We get that A mod of A plus B whole square is equal to mod A plus mod B whole square, less than equal to. By the way, so when we see this less than equal to and here comes equal, that means the value of this expression is equal to value of this expression, but both are less than this one, okay. Very important convention in inequality. Let me write it down. Suppose we write x is less than equal to y, but y is less than equal to z. So I am writing, then we will write what? Y is less than equal to z, but z is equal to t, then we will write this is equal to t. But from here finally what we can conclude? We can conclude x is less than equal to t. That is a convention. I repeat once more, x is less than equal to y, y is less than equal to z. So here we will, as y is less than equal to z, we will write here less than equal to. Now let us say z is equal to t, then we should write equal to, we should not write less than equal to. That is not the convention. So we will write in this sequence, but finally what we can conclude, x is less than equal to t. Similarly, here you see in the left hand side mod of A plus B whole square, and in the right hand side we get mod A. First we get this expression mod A square plus 2 into mod A into mod B plus mod B square, and then we get that is equal to mod A plus mod B whole square. That is why you wrote a symbol here equal to, correct. And from here what you can conclude. So let me take the next portion of the solution here, and then let me explain, okay. So from here what you can write okay. So here I wanted to show you, okay. So mod of A plus B is less than equal to mod A plus mod B. Mod of A plus B is less than equal to mod A plus mod B. So that we are concluding, correct. We are taking the square root, positive square root of both the sides. Positive square root of both the sides means what, dear students? So here it is. So let me write it down here. So we see is that mod of A plus B whole square is equal to mod A, sorry, less than equal to mod A plus mod B. Today my digital board is not working properly, so that's why there is a little disturbance in the writing. So from here we can conclude that mod of A plus B is less than equal to mod A plus mod B. Now here one remark we would like to take is that if the equality holds in a triangle inequality, as we see in this example, that is mod A equal to mod A plus mod B. So if the equality holds, then what you can say that for example, we take three vectors AC, AB and BC. Okay, so what you can write is that let me give a visual representation. Suppose this is the vector AB. Okay, so A is the initial point and B is the terminal point. Now let's consider another vector BC. So that means suppose this is the vector BC. Okay, so B is the initial point and C is the terminal point. So now obviously we see what, dear students, is that the vector AC is nothing but the vector AB plus vector B, modulus actually, sorry, let me tell you once more. The mod of the vector AC is nothing but mod of the vector AB plus mod of the vector BC. So that shows what? The ABC are collinear. So that is one remark I wanted to mention. So now, dear students, let me go to the next question, and that is going to be the last question for today's session, and I am going to place the question in front of you. Okay, so let me place the question here. The question here is, dear students, that so that the points A, and it is represented as a vector in the component form, that is minus 2 I cap plus 3 j cap plus 5 k cap. That means what? As if it is a point in the three-dimensional coordinate system with x coordinate minus 2, y coordinate 3 and z coordinate 5. Similarly, the B point is represented by the position vector I cap plus 2 j cap plus 3 k cap. That means what? The coordinates of the point B as is 1, 2, 3. Correct, na? And the position vector of the point C is 7 I cap minus k cap. That means the vector the point C is represented by a three-dimensional coordinate system as 7, 0. Why 0? J component is nothing, not mentioned. That means J component is not there. Not there means 0, and K component is minus 1. So now we need to prove that these are collinear. Okay. So what we are going to do? We find the vector AB. If you recall the vector, how to find the vector AB? So the way to find is that the I component of the vector B minus I component of the vector A, that is 1 minus minus 2, that is 1 plus 2 I cap. Then J component of the vector B minus J component of the vector A, that means 2 minus 3 J cap. Similarly, K component of the vector B, which is 3, minus K component of the vector A, which is 5, 3 minus 5 K cap. So 1 plus 2 I cap means 3 I cap, plus 2 minus 3 j cap means minus j cap, plus 3 minus 5 k cap means minus 2 k cap. So 3 I cap minus j cap minus 2 k cap, that is the vector AB. In the similar manner, the vector BC is also found out. Okay, same manner, I am not explaining again, and AC we found it out. And after that, we found the magnitude of the vector AB, that we get at square root of 14. You know how to find the magnitude of a vector. For AB, the vector AB is equal to 3 I cap minus j cap minus 2 k cap. So that means modulus of the magnitude of the vector AB, if I can write, is that what it will be, dear students. So magnitude of the vector AB will be, that is equal to square root of 3 square plus minus 1 whole square plus minus 2 whole square. Okay, so now if we find the value, so that value is actually going to square root of 14. Okay, so that's why it is square root of 14. Similarly, we can find the magnitude of the vector BC is equal to 2 square root of 14 and magnitude of the AC is equal to 3 square root of 14. Okay. Now from here what you see, AC is equal to modulus of the vector AC is equal to modulus of the vector AB plus modulus of the vector BC. So we are able to prove that one, and we can from this we can conclude the vector A, B, C are collinear. Correct. One point here, one point to notice here is that here we are not finding AB plus BC plus CA is equal to 0. That is here we find that AB plus BC plus CA equal to 0, but the point ABC do not form a vertices of a triangle. So if you see that AB plus BC plus CA, that is equal to 0. So in two ways AB plus BC plus CA can be equal to 0. Now, one is that suppose this is the vector AB. Okay. Suppose this is the vector AB. Okay. Now another vector is BC. Suppose this is the vector BC. Okay. And then there is a vector CA. So we can take the vector CA like this. Okay. So if you look into this, then also we can find AB plus BC plus C equal to 0. That is coming from the triangle. Okay, if the ABC are the vertices of a triangle. But in another way also it can happen that if you see here that AB plus BC plus C equal to 0, but ABC do not form the vertices of a triangle. They are not the vertices of a triangle. So how we are going to get that AC, mod of AC is equal to mod of AB plus mod of BC. We get, but they are not the vertices of a triangle. So that is also a point to inform you. So dear students, so with this note, let me conclude the class here. Now your task is to work on the the concerned DPP, which I will be mentioning in the class summary, and you need to work on that DPP, and we will meet in the next class. So with this note, let me conclude the class here, dear students. So if you have any question, please do let me know. Do you have any question, dear students, here?
No, sir.
Okay.
No, sir.
All right. Thank you then. We will